Hello children, today we will start our discussion from heading Chemical Properties of Group 15 Elements. And the first type of compounds of Group 15 elements are hydrides. So Group 15 elements are forming MH3 type of hydrides. Here M is any element of Group 15 and which is combining with 3 atoms of hydrogen. So MH3 types of hydride. Example, hydride of nitrogen is ammonia, of phosphorus is phosphine. Okay students, now preparation of hydrides. So only one hydride, that is phosphine, you are having in your syllabus this time. So in a lab, phosphine can be prepared by the reaction of white phosphorus with sodium hydroxide. So phosphine is formed. Bismuthine, which is the hydride of bismuth, is very unstable in nature, and all the hydrides are pyramidal structure, having pyramidal structure like ammonia. So all the hydrides in which central atom which belongs to group 15 will have one lone pair and rest 3 hydrogens. So pyramidal structure will be there of all the hydrides. Okay students, the next page. As you can see here that when we are moving from ammonia to bismuthine, the central bond angle is decreasing. Okay, so the HMH bond angle decreases with increase in the size of the central atom. So from here to here, the size of the central atom is increasing, and with the increase in the size of central atom, the central bond angle is decreasing. Now why this bond angle is decreasing? So as the size of atom, central atom is increases and the electronegativity decreases in going from nitrogen to bismuth, the electron density around the central atom decreases, and consequently the repulsive interactions between the electron pairs decreases. Hence HMH bond angle decreases in going from ammonia to bismuthine. Okay students, now detailed study of hydrides is not there this time. Then next type of compounds are halites. So group 15 elements are forming 2 types of halites. The first type MX3 type and second type MX5 type. So MX3, where group 15 elements are having 3 atoms of halogen, and in MX5 group 15 element is having 5 atoms of hydrogen. So these are the examples of trihalites and these are the pentahalites of group 15 elements. So all the trihalites are having pyramidal structure in which central atom is having one lone pair electron, and all the pentahalites are trigonal bipyramidal structure. Okay students, the next type of compounds of group 15 elements are oxides. So these are the oxides which are formed by group 15 elements. So this time you are not having detailed study of oxides of nitrogen and oxides of phosphorus. Okay students, so just you go through with the examples of oxides with the relation of oxidation state. So as you can see that in N2O, the oxidation state of nitrogen is +1. Okay, so only this oxide N2O which is having in which nitrogen is having +1 oxidation state is known. Rest all the elements are not showing such type of oxide in which their oxidation state is +1. Okay, so you just go through with these examples only. Detailed study is not there this time. Then next heading is anomalous behavior of nitrogen. Anomalous behavior, special features of nitrogen with the help of which we can differentiate hydrogen with the other elements of the same group. So why nitrogen is showing anomalous behavior? So these are the 4 points for the element due to which it is showing anomalous behavior. Okay, students. So in all the p block elements, the first element of the particular group is showing anomalous behavior, and anomalous behavior is due to the following 4 points only. So these 4 points you can use for the reason to show the anomalous behavior by the first element of the particular group in p block. Okay, students. So why nitrogen is showing anomalous behavior? The first point, it is the smallest element of the group. Then smallest size. Then next is due to smallest size, high ionization energy, high electronegativity, and absence of d orbitals. So these same 4 points you can also use for the anomalous behavior of oxygen or fluorine. Okay, students. So for oxygen and fluorine, these 4 points you can use for their anomalous behavior. Now the main points of difference between nitrogen and the other elements of group are as follows. The first point, at ordinary temperature, nitrogen is a gas while all other elements are solids. Second point, nitrogen exists as diatomic molecule while phosphorus and the other elements exist as tetraatomic molecule. Third point, due to its small size and high electronegativity, nitrogen is the only element of the group which form hydrogen bonds. Okay, so hydrogen bonds can be formed by nitrogen only in group number 15 elements. Okay, next point, nitrogen has a tendency to form p-pi multiple bonds. So what are the p-pi multiple bonds? So as the name is indicating, first thing, it is a type of pi bonding, and in this pi bonding formation, the p orbitals of the atoms are taking part. So such pi bonds which are formed due to the overlapping of p orbitals of two same atoms or two different atoms, such bonds are known as p-pi bond. So only nitrogen can form p-pi bond, but rest elements of the group can form d-pi bond. Okay, so in these pi bonds, d orbital of one atom and p orbital of other atom is taking place. The next is nitrogen shows a wide range of oxidation state, but rest all other elements are showing comparatively a low range or limited number of oxidation state. Then except NF3, the trihalites of nitrogen are unstable. Nitrogen does not form pentahalides. Why? Due to the absence of d orbitals. And the last point, due to the absence of d orbitals, nitrogen cannot form complexes. Okay, students. So in this lecture, this much only. Thank you.